Which of the following is an example of a function whose graph in the xy plane has no x-intercepts? Well, any line that has a rate of change not 0 will eventually cross. And if you have real zeros, that means you have x-intercepts. If you have at least one real zero, that means you have x-intercepts. C is the only choice. You have no zeros. It's something like a parabola above the axis or something like that. So first we can factor out a 4, and this becomes 4 times x squared plus x minus 6. And if we think of two numbers that multiply to give us 6 and add to give us 1, it's going to be 3 and 2. So this is going to become x plus 3 times x minus 2. And all of this is going to be equal to 0. So that's B, just in a slightly different order. They want this in intercept form, so we think of two numbers that multiply to give us 8 and add to give us 6. That's going to be 4 and 2, so x minus 4 and x minus 2. So remember, that's what you're doing when you're factoring. You're finding the x-intercepts. This is written in intercept form. So here we have a table where we have different values for x, but this is the one we want to pay attention to, because when we plug in a 4, we get 0. So if we plug in a 4 here, that's a 0. If the equation has these three roots, which is a factor of this polynomial? So if negative 1 creates a 0, then a factor is x plus 1. If negative 3 creates a 0, then a factor is x plus 3. And if 5 creates a 0, then a factor is x minus 5. Out of those, this is the only one that shows up. So what do we have to plug in to get 0 for y? If we plug in a negative 3 here, doesn't matter what everything else is, we multiply something by 0, it comes out as 0. We can also plug in a 2 here. What would those coordinates be? They'll be negative 3, 0, and 2, 0. So these both work. The answer is C. If negative 1 is less than or equal to a, which is less than or equal to 1, and it contains this point a, b, well, 1 would be a 0, negative 1 would be a 0, and over here is negative 2, a 0. What that means is, when you plug these in, you get 0 as the y-coordinate. So what happens if you plug in something like 0, which is halfway between? Well, that turns out to be negative 1 times 2, which is a negative 2. So that is possible. 0 is definitely possible. So just by tracing the points that we have so far and estimating what the curves might look like, I can assume that given this is my range, starting here at negative 1 all the way to 1, we're not going to go positive. That's not a possible value. Let's count the zeros. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. D is the right answer. We want 5 zeros. If we have intercepts at these 3 points, that means we have x plus 3 as a factor, x plus 1 as a factor, and x minus 1 as a factor. So I'm going to pick C. If I plug in a 4, this is true. If I plug in a 5, this is true. If I plug in a negative 3, and they want a positive value, so that rules out this one. So your answers are 4 or 5. X minus 2 is a factor of this. So we're going to multiply by another binomial to get there. X times x will give us the x squared. And notice that if we think about factoring, these two numbers multiplied together will give us b. And then if we add together our x terms, that's also going to give us b. So 2 times something is equal to b, and 2 plus something is equal to b. The number that fits there is 2. 2 times 2 is equal to 2 plus 2. So if we expand that, we get x squared minus 4x plus 4. And they want to know what is b, and b is equal to 4.